All right, so for problem number 2, we're going to use the function f of x is x cubed minus 4x to complete the following. So first we're going to go through, we're going to find the derivative. Okay, so we're going to talk about that limit definition. So we're going to do f prime of x is equal to the limit. We're going to switch to using the h approaches 0 just for the ease of writing. And then it's f of x plus h minus f of x all over h. So that's going to give us the limit as h approaches 0 of f of x plus h. Means everywhere I see an x, I write an x plus h. So I have x cubed minus 4x. So those both get replaced with x plus h's. And then I'm going to subtract off the actual f of x, x cubed minus 4x. And then make it all over h, like so. Okay. Now, a very important thing here is you need to remember to distribute the subtraction sign. It's a very common mistake to forget to distribute the subtraction sign. Don't let that be you. All right, now I have to figure out x plus h cubed. So a little sidebar up top here. X plus y to the n power, in this case cubed, we can do that using Pascal's triangle. This is actually equal to x cubed plus 3x squared h, or x squared y, sorry, plus 3xy squared plus y cubed. And if you need me to provide some information about the binomial expansion theorem, which is what this is x plus y to the nth power, it uses Pascal's triangle, which starts with a 1, a 1, and a 1, then a 1, 2, 1, a 1, 3, 3, 1, and so on, okay? If you don't know that, don't stress out about it. We can go over that in class together, okay? I can also find a video to give you guys a little bit more information about the binomial expansion theorem. But here we go. We're now going to have the limit as h approaches 0 of, so I'm going to get x cubed plus 3x squared h plus 3x h squared plus h cubed. Now I'm going to distribute this minus 4 to get minus 4x minus 4h. And then from the purple distribution, I get minus x cubed plus 4x. And then this is all over h. Which looks like a great big mess, but the nice thing about it is there are some like terms here. I can get rid of the x cubes. I can get rid of the 4x's. If you look at all these terms that remain, they all have something in common. They all have h in them. So I can actually divide out the h. So let me get rid of those orange circles. They're kind of in my way. So now I have the limit as h goes to 0. I'm going to divide out the h. So that leaves me with 3x squared plus 3xh plus h squared minus 4. Okay, so I took each of the 4 remaining terms and I divided on h. But now I'm going to plug in that h is 0. So when I plug in that h is 0, well, this is going to 0 out, and this is going to 0 out. Those are going to 0 out when I do the limit on the next line, okay? So those two things are both going to 0 out. So now we're going to have, this is equal to 3x squared minus 4. So that's what our derivative is equal to. All right, so that's the answer for part A. The derivative is 3x squared minus 4. And this is going to give us the slope of the tangent line for any x value that we want. All right, so part B of this problem, if we scroll on down, part B is use the same function to still complete the following. Part B says, find the instantaneous rate of change at x equals 2. Well, that's the slope of the tangent line at x equals 2. And the slope of the tangent line comes from the derivative, so this is really saying find f prime of 2. Well, didn't we just find that f prime of x was equal to 3x squared minus 4? And that tells us the slope of the tangent line for any x value, so I just need to plug in 2. So this is going to be 3 times 2 squared minus 4, which gives me 12 minus 4. Comes out to 8. So that's the instantaneous rate of change or the slope of the tangent line at x equals 2. All right, so that's our answer for that problem. All right, and now we've got part C. Part C says to write the equation of the line tangent to f of x at the point 1, negative 3. And to write the equation of a line, we need a point and we need a slope. Well, here's our point, but now we need a slope. So I need to know, well, what's the slope of the tangent line there? Well, that comes from the derivative. In this case, it's f prime of 1. So I'm going to do 3 times 1 squared minus 4. So I get 3 minus 4 comes out to negative 1. So that's my slope of the tangent line. Okay? So now I have a slope and I have a point at 1, negative 3. So I want to write the equation of the line. Well, I'm going to go with point slope form. Y minus y1 equals m times x minus x1. And I can just fill in the blanks. So y minus the y value minus negative 3 is plus 3 equals the slope, negative 1, times x minus the x value, 1. And you could stop there, okay? Point slope form is totally acceptable to leave. It's actually preferred in most cases. But I could also go as far as y equals mx plus b. This would be negative x minus 2, okay? So either one of these answers would be perfectly fine. It's whichever format you prefer.